finishing up kind of the discussion. I know we can't have live discussion, so it's more me summing up what you guys learned from TWIG and from the Explore activities you've done and some of the experiments that virtual or simulations that you've done. All right, so we talked about Newton's first law of motion, and we talked about inertia and balance and balanced force. We will talk more about what does it mean when we say balanced and unbalanced force. But before I move on to these forces, I'm just gonna talk about state of motion. So what is state of motion? All right. Really quick, let's review inertia. I know I've wrote this so many times, but inertia is the tendency of an object to resist changes in its velocity. All right, so when we talk and its velocity, and of course when we say velocity, that means we're talking about state of motion as well. All right, so an object will not change its state of motion or its velocity unless it's acted upon an unbalanced force, right? So this is the main idea behind the state of motion, okay? So let's see here. Let's say I have a just gonna do an example. I think that's example 4. So for example 4, let's say I have a 4 kilogram object is moving across the friction or a friction-free surface and it has a constant velocity that is equal to 2 meters per second. All right, so what do you think the force that is needed for this object to move? So which horizontal force, so what is the horizontal force needed for this object to move? So it's moving across a horizontal surface. I did not even write a horizontal. Oh, here it is. All right. So, but there is no friction, right? So when there is no friction, then it's moving at a very constant speed, right? So when it's moving at a constant speed, what's happening? That means it does not, and it doesn't have a friction, or the surface does not have a friction on the object. That means it does not need any force. So this is just your answer, that it doesn't need any force. And we're going to write why, because as you know, we have to use CERs and kind of prove with evidence and reasoning why we chose the answer we chose. All right, so we will say If an object is in motion, it will stay in motion with the same motion characteristics. So it shouldn't take any force for the object to maintain the same state of motion. So let's write this down. It doesn't, so here one, that's two. It doesn't take any force to maintain that same state of motion. Okay? So in other words, if there is a force acted upon that object, then there will be a change in the speed, which will cause the acceleration, and in this case, there will not be Newton's first law of motion. Okay? Now, as I said earlier, now this comes when we talk about, when I say probably the force acted upon the object, there are some forces that when applied, it will still keep my object in the same speed. So it will not really affect the speed of the object. And that's what I mentioned earlier when I said, what do I mean by balanced or unbalanced force? Like, force is force, right? Yeah, and you think that every time I give force or push or any type of motion to that object, that means there is a force acted upon that object, which means there shouldn't be Newton's first law. Well, some of the forces will not change the speed or the velocity of that object. And here comes the concept of balanced or unbalanced forces. And this is really important for you to understand the concept behind unbalanced and balanced forces. What does unbalanced force mean? So let's talk about this notebook here. What do I have in this notebook? It's just on the table, right? Is there a force acting upon that notebook? I hope you answered yes, even though it's just at rest, it's not moving. But yes, there is force acting upon that object. And what is this force? It is the gravitational force, that the Earth's gravitational pull that is pulling downwards towards the Earth, right? The other force is the push of the table on the book. So I have two forces acting upon that object. Let's write this down, and then we'll come up with the conclusion together. So one, there are, okay, let's do this. Let's consider a physics book or physics notebook at rest on a tabletop. So there are two forces. I'm just summing up what I said, acting upon the book. So force one is one force is what we call the earth gravitational pull, and this is pulling downwards. All right, the other force is going to be the push of the table on the book, and that push of the table on the book is called the normal force, which is pushing upward on the book. Okay, and this way actually the book is not floating, right? So if we want to, let me show you this in a diagram. So if I have, that is my table right here. Okay, and you have that physics book right here. Physics notebook right here. So the gravitational force is that force that is pulling downward. That's gravity pulls downward on the book. Okay? And then I have another force that is going upwards, right? And that is the table pushes upward on the book. All right, so let's talk more about this. So since the two forces are equal in magnitude and in opposite direction, that means they're going to balance out each other, because the same force pulling downward is the same force that is pushing upwards. And this is what we call the equilibrium state of equilibrium. Okay? All right, so that's what we're going to say. We're going to say since these two forces are of equal magnitude and in opposite directions, They balance each other. Okay? So we say that the book is said to be at equilibrium. All right. So there is no unbalanced force acting upon the book. So let me write this. So in other words, it will not accelerate. That means no acceleration. Okay? So it's important to recognize that these are equal in magnitude and in opposite direction. Equal in magnitude, that means their value is the same. So the same amount of force pulling downward is the same as the one pulling upwards. So this is your balanced force. So you know what? I should have done this. I'm sorry. Let's do balanced force and let's now talk about what is an unbalanced force. What is an unbalanced force? So what we're going to do, we will consider a book sliding. So let's do the same concept. I got this table and I have a physics notebook here. Okay, and automatically, without even anyone telling me, I should right away know that I'm going to have two forces, which is the gravity, because the gravity pulling downwards is in every single, even us as people, like human beings, we always have this force that is pulling downwards. Hello? Yes. Okay, I'm coming. Al-Agha? All right. Oh, okay, I'm coming down. Thank you. Bye. Pulls downwards. You know what? I'm going to have to stop here and I'll